Today we're going to be looking at trig graph identification. What I have here is I've got the standard graphs that you really should get to know. You really should be able to sketch these graphs as well so that you really understand them, because everything that we do in this section here is going to be based on these graphs. So the red graph here is our sine graph, as you can see, coming up, down and finishing here at 360 degrees, going up to a maximum of 1 and a minimum of 1 over here. The cosine graph you can see is here in blue, coming down through here, and this one here also has a period, which is when it starts to repeat itself, of 360 degrees. Okay, it goes up to a maximum of 1 and a minimum of 1 here. The green graph is the tan graph. It is different, it has a period of 180 degrees, and in that way it's different from the sine and the cosine graph. But you really need to get to know these, you need to be able to draw them. Okay, let's look at what we're doing today, and this is applicable to National 5 and also higher. So what we're looking at is, we're looking at how the graphs move based on changing some numbers that would appear as A, B, C or D, or a combination of them. Now this looks quite complicated, but what we're going to do is we're going to step through each of the letters to show what each of the letters would do if I replaced it with a number. Right then, so let's have a quick look here at what we've got. So I've got an A value that would appear in front of sine or cosine. For the examples I'm using here, I'm just using a sine graph. Okay, so for the A, what we're looking at is this black graph here being the normal sine graph. And what I've done is I've changed it in some way. It's got a bit higher and a bit lower here. So what I've actually done is I've multiplied the values, the y values of the sine graph by a certain number. And that's the number that appears in here. So the A is actually the amplitude, and what that means is how much I'm going to multiply these values by to get to the next part of the graph. So I'm multiplying the y coordinates here. So what I can see here is that I've multiplied the 1 really by 2 to get the graph going up to there, and if I just check here as well, yeah, that's gone down to there as well. So the graph that I have here is y is equal to 2 sine x. Okay, so I've multiplied it by 2, so I'm just really stretching it up the way and down the way, okay? Just stretching the graph. If I look at B and what B would do, so B tells me the number of cycles. Okay, that's what B is going to do for me. So if I look down to this graph here, I've got the normal sine graph, which will be in the black here, goes up to 360 degrees. That's a normal for the graph, but I've got a blue graph that's kind of compressed a bit in, or it could be extended out a bit further. But in this one here, and in general, you'll probably see them being compressed in the way. And what I can see is within the 360 degrees where my normal 1 cycle is, I can see I have 1, 2 cycles. So this graph here would be y is equal to, and I'm just going up to 1 and minus 1 here, so it'll just be sine, and where the b value is, that would be a 2x, and that's what that would be. And another thing that I can see here is that in this graph, I can see that the graph starts to repeat after 180 degrees, and that's called the period. So that would now be the period of the graph. And the period can be worked out, period will be worked out by dividing the normal cycle for 1 cycle and dividing that by the number that we're given, which would be b. So 360 divided by 2 would give me the period of 180 here. If I now look at the value, if I placed a value in here where c is, that would be within a bracket. What that would do is that would move the graph from left or to the right. And the c value here is called the phase angle. Okay, so the phase angle, if I'm moving the graph to the left, now this is where it's strange, that would be positive, and if I move the graph to the right, that would be negative. Okay, if I look at this graph here, I can see that the normal sine graph is the black one again. I've moved this graph to the right by an amount, and I can see that that's 30 degrees I've moved it by. So what I can say is that this graph here would be y is equal to, I'm just going up to 1 and minus 1 again, so that would be just sine, I'd open a bracket, and it's just x minus 30 degrees. So I've moved it along to the right by 30 degrees, and that's why it's a minus 30. If I look at a value for d, so what d is going to do for us, so d is really just going to be the up and down. Okay, so it's just up and down movement. And for the up, it's going to be positive. For down, it's going to be negative. So all I'm going to do is I'm just going to grab the graph and just lift the whole thing up the way if it's a positive number, or grab it and pull it down the y-axis if it's a negative number. So in this one here, what I can see is that instead of starting at 0, I'm starting at 2, and the graph just goes up to 3 and down to 1, so it just goes up 1 and down 1. From this point here, this is where it oscillates about, and what I can say there is that this graph here would just be a y is equal to, and it's just a sine graph again, and all I've done is taken the sine graph and just pulled it up the way by 2, so that would just be a plus 2 there. So y is equal to sine x plus 2. So this is the type of movement that we're going to be involved in. We're going to have to try and identify graphs that may have a combination of these movements, and that's what we're going to do now. And like any of the clips that I've got, what you can do is you can freeze the video and you can try the questions yourself and then see what the answers are as I complete them. Okay, let's have a look at this one here. Okay, so what we're going to do is we're just going to identify these, and the only movement that I'm going to make is with the letter that's at the front, and that was the A, which is the amplitude. Okay, so you can freeze it and try and do these right now. I'm going to give you the solutions. Looking at this graph here, I can see that instead of the graph going up to 1, coming back through 180, and finishing here at 360, it's gone up to 5 and minus 5. So the graph is still oscillating about this axis here, which is the 0 value. So quite simply, this one is y is equal to, it's been multiplied by 5, it's a sine graph, and I've not changed anything else. The next one, it's just been multiplied by 3, so y is equal to 3 sine x. This graph here is a cosine graph, so it's going to be y is equal to cosine, and it's cycle, yep, so all I'm changing is just the a value, the value at the front, so that's going up to 4 and down to minus 4, so that's going to be a value of 4 that's going to be in there, so that's going to be y is equal to 4 cos x. This graph here, up to 12, down to minus 12, it's a cosine graph, so y is equal to 12 cosine x. This graph here, this goes up to 6 and goes down to minus 6, but it looks a bit different from the kind of sine graphs that I've been working before, or the cosine graphs. It's gone down the way instead of starting going up the way, so what that tells me is that I'm going to have a negative value that's going to appear in there. It goes up to 6 and minus 6, so it's going to be a minus 6, it's a sine graph x, just because it starts going down the way rather than going up the way like the normal graph that we see. Again, we've got a negative graph here. It's going up to 8 and minus 8. So what I'm starting with is y is equal to minus 8 because it's a cosine graph that's starting going up instead of down. Cosine x. Okay, so that's the first 6 that we've done there. Right, let's add in the other letter. What we'll do is we'll add in the letter B. So if I put in the letter B as well, so what I'm going to do is I'm going to have these graphs here are going to be looking like a combination of having a number in A and a number also in B for both cosine and also for sine at this stage here. Right, so if I remember what the A value does, what it does is it increases the graph by multiplying the y coordinates, so that goes up to 3 and minus 3, so that's again balanced around about the x-axis, which is 0. I can see it's a sine graph, so what I'll do is I'll write down what I know already, so it's going to be a sine graph. Normally the sine graph has one cycle within 360, this one has one cycle to there, two cycles to there, so that's going to be a 2x value there, and already what I know is for the A value it's going to be a 3. So y is equal to 3 sine 2x. Looking at this graph here, and again you can freeze it and try the questions yourself. So this graph here is looking like a cosine graph. It's going up to 10 and down to minus 10, so I can see it's going to be a 10 cosine, and the cosine graph I can see that there's two periods in 360, one to there and another one to there, so that's going to be 2x there. Just be careful when you do this type of work. When you're working with the change of the letter that's in there that tells you the number of cycles, always check to see that the graph goes up to 360, because sometimes it doesn't, and that could throw you a wee bit when you're doing your questions. Let's look at this question here. I can see it's a cosine graph starting up there, going from 2 down to minus 2, so it oscillates about 0. So I'm going to go for y is equal to 2 cosine, and I'm going to count how many cycles there are. It goes up to 360, so we've got 1 cycle, 2 cycles, 3 cycles, 4 cycles. 4x. They're the only things that I'm changing at this time. Look at this graph here. It's a sine graph, so y is equal to, and I'm going to go up 5 and down minus 5. Yep, so that's going to be 5 sine, and I'm going to count the cycles. So there's 1 cycle to there, 2 cycles to there, 3 cycles to there at 360. So that's going to be y is equal to 5 sine 3x. Right, let's have a look at cosine, the next two graphs here. And again, the difference with these ones here, there's something different. All I'm changing is the letters A and the letters B, so if you can try and work out what these ones are, go ahead. The solution for these ones, I can see that they start down the way and going from down going up instead of starting that way, so it looks like a negative graph. It's a negative cosine graph, goes up to 5 and minus 5, so I'm going to go for y is equal to minus 5 cosine, and I've got 1 cycle to there, 2 cycles to there, 2x, so that's minus 5 cosine 2x. This graph here, this looks like a normal sine graph. It goes up to 3 and goes to minus 3, but what I'd said, remember, be careful about the x-axis. This x-axis goes up to 720, so normally what I would have is 1 cycle to here. I've only got half a cycle, so this graph here will be y is equal to 3, because of the movement on this way here. It's a sine graph, and it's going to be a half x, because I've only got half a cycle in 360 degrees that's there. So don't be thrown by what you see there. If you just assume that that's 360, then you may get that one wrong. Let's look at a couple of tan graphs that are here. And again, what I'm looking at here, I'm only looking at the movement from left to right. Okay, sorry, from how many cycles there are within the normal cycle. So this one here is just our normal graph. So this is just y is equal to tan x. So that's the way it should be normally. And remember, the difference with the tan graph, it tells you that there's only 1 cycle between 0 and 180. So that's 1 cycle. So if I look at this graph here, it's a tan graph, I can see, and there's 2 cycles within 180, so this is going to be y is equal to tan 2x. For B here, I can see that, well, the graph goes up to 720 again, so I can see that there's only 1 cycle up to 360, so there's only a half cycle up to 180, so y is equal to tan, and that will be a half x. This graph here only going up to 180 now. Okay, so normally within 180 there's only one cycle, but what I have here is 1, 2, 3, 4 cycles. So y is equal to tan 4x. Okay, so that's just looked at the letters A and B and a combination of both of them. Let's now start looking at the letter that was C and see what that does for us. Remember, C is the phase angle. If it's a positive value, it's pulled the graph to the left. If it's a negative value, the graph is to the right. Okay, on these questions here, I can see that we're only going up to 1 and minus 1, okay, on these 4 graphs here. So I won't have a number for A, so all I'm really interested in is how it's sliding back and forward. If I look at the values that are in here, they're a bit different from just the 360 degrees that I'm normally seeing, but that's because the graph has moved one way or the other. I can see this graph is a sine graph, so y is equal to sine. It's been pulled to the left a bit, so I can see I don't know how much that is, but if I look at some of the other values, I've got 80, and that's peaked up there. Normally that would be at 90. So that would normally be here somewhere, that would be at 90, so I've moved it 10 degrees to the left. Normally it would come through at 180, so it's moved 10 degrees to the left. Normally it finishes at 360, moved 10 degrees to the left. So this one here will be x, and the C value that I'm going to put in here is a plus 10. Remember, this is just a bit awkward because moving to the left is a positive. Okay, you can freeze the video and try the graphs that I've got here. Here's the solutions. What I've done is I've moved the graph along to the right. So again, it's a sine graph. So y is equal to sine, and it's going to be x, and we've moved it to the right by 40 degrees. Yep, I'll just check it here. Normally this goes through at 180, moved at 40, yep, that's 220. Normally 360. Moved at 40 degrees, yep, so that's going to be minus 40 degrees because it's moved to the right. This graph here, it's a cosine graph. I've moved the graph to the right by 25 degrees, so it's going to be minus 25. And I can always just check that with each of the values that are here. This graph here, let's see what we've got. So it's a cosine graph. And what we'll go for is, I've moved it along, usually that's 90 degrees that the graph would come through here, so I've moved it to the left by 30, and usually it comes back through the axis at 270, yep, so I've moved it by 30 to the left, so that'll be a plus 30 degrees that's there. So y is equal to cosine x plus 30. Right, let's have another look at some of these ones. What we've got here is I've moved the graph, moved it, looks like 37 degrees. It's normally a sine graph, this one here, so this one would appear as y is equal to sine x, and I think I've moved it 37 degrees to the right. Let's check it here as well. That's usually 180, 37 degrees to the right, yep, 37 degrees to the right. So that's going to be minus 37 degrees because it's moved to the right hand side. This graph here, y is equal to, so it's a cosine graph. It's up to 1 and minus 1. Yep, so it's going to be an x, and what I've done is I've moved it to the left. Normally that would be at 90 degrees that would come through, so I've moved it to the left by 45 degrees. Yep, moved that by 45 degrees. Yep, so that's going to be a plus 45 degrees. Okay, so looking at these graphs here, G and H, I can see that they go up to 3 and minus 3. This one goes to 5 and minus 5. So I'm going to take that into consideration as well when I write down the equation of this graph. So I can see it's a sine graph. So y is equal to sine. It's been shifted along by 30 degrees to the left, as I can see from both these values, because that should be through here at 180. That should be starting at 0. So that's going to be x minus 30 degrees. And what I've got here is I can see it's up to 3 and minus 3, so I'm going to put a 3 in there. Okay, so y is equal to 3 sine x minus 30 degrees. This graph here, I can see it's a cosine graph we could go for. Okay, so y is equal to a cosine graph. What I've done is I've moved this graph. Let's see what have we got. So it would usually start at 0, it would come through here at 90, so I've moved it by 35 degrees to the left. Yep, that's usually through there at 270, so I've moved it by 35 degrees to the left, so that will be a plus 35 degrees that's going to appear there. It goes up to 5 and minus 5, so that's going to be a 5 that would appear there. So y is equal to 5 cosine x plus 35 degrees. Let's have a look at a tan graph from this type of work as well, and what we'll look at is just how the graph is sliding along the way. Okay, so this one here is our normal tan graph. So this one here is y is equal to tan x. It usually starts at 0 and goes all the way up at 90 and restarts at 90. This time here, what we've got is instead of starting at 0, looks as though we've moved it to the right by 45. Yep. And usually it goes through here at 180, but it's moved along again by 45 degrees. So what this will give us is y is equal to tan, and it's going to be x. It's moved to the right, so it's a minus, okay? 45 degrees. Okay, so let's look at some of these graphs that would include possibly all the movement that we've got. So we're going to be thinking about all of the movement, which would be the A, the B, the C, and possibly the D as well. Right, this graph here, if I look at this one first of all, there's a difference here in the coordinates where it goes up to 7 and goes down to minus 3. So if I look at that there, what I'd be thinking of doing is trying to work out where the graph is centred about, okay, or where it oscillates about. And a simple way to do that, and this is working out our, trying to work out our value for D, a simple way to do that would be to add these two values together. So 7 plus minus 3 will give me 4, and divide that by 2. So I'm just taking the mean of these two numbers, and that should give me 2. So that value there should be 2. So what I can tell is that the graph has just been lifted up that way by 2. So I would expect that my D value is going to be 2. I can see it's a sine graph, so what I could say is y is equal to, and we'll go for a sine graph. It's only got one cycle, so there won't be any B value that's there. So that will just be x, and I've not got any slide on it, so it's just going to be x on its own, and I said it's going up by 2 places that's there. Right, so from here then I need to work out the value for A. So the value for A will be worked out from this point here. So I can see that from 2 up to 7, that's 5. And I can see from 2 down to minus 3, that's also 5 down that way. So the value for A is going to be 5. So the graph's got an amplitude of 5. It's not slid along the way, it's just lifted up by 2. To the next graph here, what we'll do is we'll look at how this graph is. This is another sine graph, so I'll start off by saying y is equal to, and we'll go for sine. I've got only one cycle, so it's just going to be an x that's going to appear there. And let's see, I've just pulled it down the way by an amount. So let's add these two together here. So that should give me minus 4 plus 2 will give me minus 2, and half of that should tell me that the graph is running around, or it's oscillating about minus 1. So I'm going to put a minus 1 in there for the D value. I'm then going to be working out from there down to here. How far is that? And that's 3. From there up to there, that there is 3 as well. So that tells me that the A value is 3. So y is equal to 3 sine x minus 1. this one here, okay? So what we've got is we're going from 0 down to -1. So it's a graph again that's been pulled down the way. It's a sine graph. So y is equal to sine. There's only one cycle. And if I think about adding these together, I get -1. Divide them by 2, I get -1/2. So I could put that as -0.5. Okay? And that's where the graph is oscillating about. If I think about the amplitude from there to there, that's going to be 0.5 as well. And from there to there, 0.5. So what I've got is for my d value, I've pulled the graph down by -0.5. And what we've got is our amplitude is 0.5. Okay, so that'd be 0.5 in there as well. This graph here, again, just one cycle. It's a cosine graph this time. So I've got y is equal to, and it's a cosine. It's only one cycle, so I'm going to put an x in there. And I can see that the graph's moved up the way by some amount. Add these together, and I get 2. 2 divided by 2 gives me 1. So I know that the graph is oscillating around about 1. Okay, so then I'll work out what my amplitude is. So the amplitude from there up to the maximum point is going to be 4, and from there down to the minimum point that's there is going to be 4 also. So I've moved the graph up by 1, so it'll be a +1, and my amplitude is 4, so that's a 4 that's going to appear in there. Okay, so I've got 4 more graphs to do. So if you can try these ones, have a go at them and see how well you do. These are the last 4. Okay, so for the solutions for these ones, let's go for looking at the graph. Right, so this one here, remember that's a bit different again. So that's it's changed. So it's going to be a negative value that I'm going to have for my amplitude. I can see it's meant to be a cosine graph. It's an upside down cosine graph. So I'll go for y is equal to cosine. I've only got one cycle again, so that makes it a bit easier for me. Cosine x, and I've moved the graph up a bit. So 12 plus the -4 will give me 8, and divided by 2 will give me 4. So the graph must be oscillating about the point 4. So I've moved it up by 4. What I'm going to do then is I'm going to try and work out what the value is for my amplitude. So 4 to 12, or 12 take away 4 will give me 8, and again for down to here, that's going to be a value of 8. But remember, it's starting from going up the way instead of going down the way, so that's going to be a -8 that's going to appear in there. So the equation of that graph is y is equal to -8 cosine x plus 4. Looking at this one here, right, so check that out there. So that's not gone all the way to 360 degrees, so that's going to tell me something different. So that's going to give me a value for b. I can see it should be a sine graph, so I'm going to start off with y is equal to a sine, and I can see that the period of the graph is 120, so how many of them would be in 360? So 360 divided by 120 is going to give me a value of 3. So that will be the number of cycles that I've got. So that's going to be a 3 in there and an x. I've not slid the graph anyway from left to right. And what I've got is I've moved the graph up by some amount. So I want to know what that value is that's going to be here. Add these two together. So that's going to give me a value of 6. Divide 6 by 2. That should give me 3. So this should be 3 here. So I should have lifted the graph up by 3. So that gives me my d value that's there. I see the graph is going in the opposite direction than the sine graph normally goes, so it's going to be a negative value. And if I look at what my amplitude is, my amplitude from there to there is 6, and from there to there, that's 6. So what I've got is a -6 appearing in there. So y is equal to -6 sine 3x plus 3. So getting a bit more complicated. Last two that we've got here, we've got a graph going up to 15 and down to -25. Right, so what I want to know is how many cycles are there first of all. So there's only one cycle, so that's going to have no value for b, or just 1 for b. And I know it's meant to be a cosine graph, but it's upside down, so I'm going to go for y is equal to, it's a cosine graph. I know that there's only one cycle, so it's an x. I've moved the graph in some way down, so I want to know what value is that we've moved this down by. So I need to try and find out what the graph is oscillating about. If I add these two together here, 15 plus minus 25, what does that give me? That gives me 10, that would be. So let's see, if that's 10, half of the minus 10 that would give me, minus 10 that will give me minus 5. So I know that that value there is minus 5. So I've pulled the graph down by 5 places, so the value for D is going to be minus 5. Right, so I know it's going to be a negative value that I'm going to have in here, because the graph's starting going up the way, cosine graph, and all I need to do is work out my amplitude now. So from minus 5 up to 15, that's going to give me 20, and from minus 5 to minus 25, that's 20 also. So there we go, it's a minus 20 that should appear in there. So y is equal to minus 20 cosine x minus 5. Last graph. Right, so what I've got here is a kind of sine graph, it looks like. I don't have 360 degrees. What I've got is a period of the graph going to 180. So the number of cycles will be 360 divided by 180, which equals 2. So the b value that I've got is going to be 2. I know it's a sine graph, so I'm going to start off by putting in sine. I know it's a 2 that's there, so that's going to be a 2x. And I've moved the graph down by some amount. So I want to know what value is that graph oscillating about there. So if I add the two of these together, I should get minus 1.6. Divide that, should give me minus 0.8. So it'll be minus 0.8 that appears there, and that will be the value that I've pulled the graph down, so that will be the D value. So that's minus 0.8 that goes there. I'm going to find out how it from this point here, what is the amplitude. So from minus 0.8 up to 2.5, that's 3.3, and I'll just check it going down the way as well. Yep, that's 3.3 that way. So that's going to be a normal graph, so it's going to be 3.3 that appears at the front there. Okay, so the equation, this graph that's here is y is equal to 3.3 sine 2x minus 0.8. And that's the last question in this type of work here. So this is applicable for National 5 and higher. Remember, at higher, what you'd be doing is you'd be working in radians as well, and perhaps some of these graphs would be in radians. I hope this has helped you to work some of the things out and given you an insight into working out how to identify trig graphs, and hopefully now you ken maths.